Here we're going to look at the dynamic routing protocol RIP. RIP has 3 versions, RIP version 1, RIP version 2 we use with IPv4, and RIPng we use for or with IPv6. I'm going to first cover RIP for IPv4, and then we'll go over a little bit of configuration, and then we'll cover RIPng and go over a little configuration there. RIP is a distance vector interior gateway protocol, meaning we use it within our autonomous system, right, not between autonomous systems. And it uses distance and direction, or distance and vector, to make its decisions. Its administrative distance is 120. If you recall, administrative distance is used as a measure of trustworthiness when you have multiple routes, or you have a route within multiple routing protocols, the same route. So you're running multiple routing protocols within your network. For example, EIGRP and RIP together, and they both have a route to a particular destination, administrative distance will be used. EIGRP has an administrative distance of 90, and RIP has an administrative distance of 120, so the lower the administrative distance, the better. EIGRP route would be chosen. Just as a sidebar, connected routes have an administrative distance of 0, and static routes have administrative distance of 1. I suppose making the assumption that if you as the administrator typed in the route, it's the most correct route. Metric is the hop that RIP uses. I'm sorry, wow, metric. The metric that RIP uses is hop count, which is the number of routers it goes through. So every time it goes through a router, that's a hop. Its maximum is 15, so anything beyond 15 is considered a dead. You won't be able to get there. RIP version 1 is classful, and I really only am including version 1 in here just for historical reasons, so we have a full picture. And I won't be configuring version 1. It's classful, meaning I can't do VLSM, right? It won't send subnet information with its updates. So everything I have to use classful IPv4 addresses. So if I use a 10.1.1.1 address, then the network for that address, if it's RIP version 1, has to be 10.0.0.0, because it goes back to those classful boundaries. And if you remember, if it has a 10 in the first octet, it only has an 8-bit subnet mask. RIP version 2 is classless, which means it will send subnet information along with its routing updates. So I can go ahead and do variable length subnet masking with it. So I can do my 10.1.1.1 IP address, and I can give it a 24-bit subnet mask, and now that network is 10.1.1.0. RIP version 2 can handle that. RIP version 2 automatically summarizes at classful boundaries, but you can disable auto summarization and then manually summarize it, which I'll show you, and we'll look at that. RIP version 2 uses multicast. So RIP version 1 broadcasts routing updates or routing information, whereas RIP version 2 multicasts it to those that are interested or participating in RIP. Its multicast address is 224.0.0.9. Transport protocol RIP uses is UDP, and it uses port 520. And it's also capable of doing equal cost load balancing. By default, it'll automatically load balance over 4 equal cost paths. You can increase or decrease that using the maximum paths command. So now let's go ahead and configure it. It's relatively easy to configure. Here's the topology we're going to work with. We have a branch router, a headquarters or an HQ router, and we have a branch 2 router. Here I have 3 different networks connected to branch 1. If you could envision them, these would be like your internal LAN, and maybe you've subnetted this into multiple different subnets. These are all your users. I don't know, maybe this guy's accounting, right? Marketing, who knows? Whatever you subnetted, but for whatever reason you have 3 subnets within this branch. I've shown the picture here so you can visualize it. But in fact, there are no computers back here. What I've done is I've just configured a loopback address with this network address in .1. So this address here is 10.1.1.1 on this loopback interface. Loopbacks are a great way when you just want to minimize your equipment usage to test things. We use loopbacks for a lot of times so you can see the different routes, the different networks, because if you remember correctly, routing doesn't need to happen if everything's directly connected. Meaning, without routing, I can ping from branch 1 to HQ 192.168.1.1. When I want to go through HQ to get to the other side, that's when I need routing. Right? So Sometimes I just like to simulate a bunch of different networks so we can see larger routing tables. We can do some things. Specifically, we're going to do some manual summarization with these 3 networks. And then on this side, I've kind of connotated, would be the word. I have done another loopback address of 10.1.4.1 on branch 2, but I've also shown it like you would normally see if somebody configured a loopback address. So if you're working on labs or things like that and you see this, what this probably means is, they've used a loopback address. They'll probably have an LO here to know for sure, or just somehow signify this is the network on this side of the LAN. So anyway, so your setup is 3 routers, 3 loopback addresses, or 3 loopback interfaces here, 1 loopback interface here. Let's go ahead and configure it. I've already configured all the IP addresses. Now all we'd have to do is configure RIP and make sure it runs on all the interfaces we want it to run on. So we'll start with configuring RIP version 2 on branch 1. Pretty simple, and I'm sure it's review for many of you, but hopefully I'll throw some things in here that I will remind you of some important details as we go through. Router RIP, by default it's version 1, so we want to go ahead and tell it it's going to be version 2. Our addresses on here are 10.1.1, 10.1.1.1, 10.1.2.1, 10.1.3.1, and 192.168.1.0. I'm sorry, 1.1, which will connect up to HQ. So we want RIP to run on all of those interfaces. So we'll do network 10.1.1. They're all 24-bit subnet masks, if you remember from the topology picture. And some of you are saying, wait, what's going on? I'm going to show you something. Okay, so whoops. Network 10, we said 10.1.2.1, so that'd be .0 if it's 24-bit, and 10.1.3.0, and then we want it also to run on that link between branch 1 and HQ, so 192.168.1.0. Okay. Exit or end. Now I want to show it to you, and some of you are already going to see it. You already know, and it reminds you. But we're going to go ahead and do it anyway. So let's go show run. Begin. I want to start in the show run because sometimes you really get going with this stuff, as some of you might know, and you could have pages and pages of config, and it's long, you don't want to go through it. So we can do one of many things we can do is pipe to begin, and we want to begin the first time it sees RIP. So the first time it sees RIP in my configuration is the first part of the output, and then it just lets it go the rest of the way. Notice what I wanted you to notice, that some of you may have remembered, is that automatically in my running config and in my startup config it's going to show up as 10.0.0.0. Okay. If I take off auto summary, it's still going to show up this way. The difference is when I take off auto summary, when I do a no auto summary, it'll send subnet information out with its routing advertisements. Alright, let's go ahead and configure the rest of it. So we want to configure HQ and next, and then branch. Alright, so pull up HQ, same thing, right? Config T, router RIP, version 2. And the networks here are 192.168.1.0, that's the one directly connected to branch 1. And then the other one is network, it's network 192.168.2.0, that's the one connected to branch 2. I have no loopbacks configured on here, so we can go ahead and be done with that, and it is actually done right now. If we do a show IP route, well, let's see if I can get it. There we go. Wow, 3 times I still didn't get it. Show IP route. There we go. And you also notice that now it also is learning about that 10 network from 192.168.1.1, which is branch 1. Also, what I want you to notice is it summarized back to classical boundaries, which would be 8 bits. Its administrative distance is 120. Its metric is 1, so 1 hop. Alright, now we'll go ahead and do branch 2. Router RIP, network, and branch 2 has 192.168.2.0, that's the one connected to HQ. Oh, sorry. A little too fast. There we go, 192.168.2.0. And then I also had the one loopback, 10.1.4.0. And again, I didn't need to type that in. I just had 10.1.4.0 in my brain. Because if we, now last time I exited out as you go through these, you'll notice I just keep throwing kind of little things in here. I hope you pick up along the way instead of, lecturing about every little possibility that there is. I just kind of throw things out there. So the first time I actually typed in end, went back to privilege exec mode, and then did a show run. So now from here we can also do the do command instead of exiting back. So we'll do show run begin rip. And it did the same thing. And it should do this. This is normal. It was just me thinking about, okay, the network is this, and I'm regurgitating it back. But so here's our networks. Now here is where a little bit of a problem comes in. Let me bring my topology back over. I'm going to get my pen back out, but first I'm going to get everything off of here. Here's where we have a little bit of an issue. These are all classful, right? Or not classful, I'm sorry. These are all 8 bits. They're class A address. This is a class A address. When I send subnet information with it, RIP will correctly see it as 10.1.1.0. So the network's 10.1.1, right? Or 10.1.2 or 10.1.3. However, when I have auto summary on, it goes back to its classful boundary. Well, what is that classful boundary for the 10 networks? It's all going to be 10.0.0.0. Let's go ahead and kind of wanted a bigger. I wonder if I can. Ooh, that's not it. Sorry, I'm just trying to find a good pen. See, if I switch to my actual pen, it goes thinner. I'll have to figure that out. So anyway, the actual classful boundary then is 10.0.0.0. Or I'm sorry, the actual network. That's the network being advertised out. So if you want to get to anything within the 10.0.0, let's make that more of a 0 and less of a 6. Right? He's going to learn about 10.0.0. He's going to learn to go that way. Problem is over here, we're summarizing also. Over here is 10.0.0 also. Oh, lost my pen again. Hold on, sorry. This guy here on this side now is also advertising out the 10.0 network, right? So now HQ also says, well, if I want to get to anything in the 10.0.0 network, it's got to be that way. I hope you can visualize the confusion that's going to happen here, right? If it happens to go the correct way, right? So let's say I want to ping 10.1.1.0 and it happens to choose this route, it may actually get a response. But what happens if I want to go to 10.1.4.0 and this is still the best route according to its routing table, according to its metric, right? It will never get from here to here. And we'll demonstrate that and we'll fix it. And it has to do with having these discontiguous networks in between and our summarization. So we'll turn that off and we'll do some manual summarization and we'll just see how that behaves, and then we'll cover RIPng. So we're first going to go back to HQ and just demonstrate that hopefully that is the fact. It should be the fact. But show IP route. But just because we in theory know something's going to happen a certain way doesn't always mean that it's true. And right now it's not showing up. It should though. Wait, did we remember to finish it? Yeah, I think we did. I better pull branch 2 back over just to double check. Alright, so let's go ahead and see what we thought should happen when we drew our picture, if that's what actually happens. So we have HQ up. If we do a show IP route, and it is there. When I stopped to troubleshoot in hindsight, I should have done it with you guys, but what had happened when we didn't see it the first time was because branch 2, when we configured RIP, we didn't do version 2, and so they didn't update each other. And as soon as I fixed it to version 2, we were fine. It works, and now we have both the routes that we expected to have, right? So HQ has a route to 10.0.0.0. via 2.2. So if it goes towards branch 2, it can get to 10.0.0.0. If it goes to 1.1, it can get to 10.0.0.0. These should be, I guess I didn't look, should be equal cost paths. Links are the same, devices are the same, one, right to it. So it should kind of load balance. So, we'll go ahead and what we should discover is that our pings just aren't quite going to work like we wanted them to, right? So we'll go from branch 1 and we'll try to ping 10.1.4.1, and it's not going to work because it doesn't believe that it has to leave the router to do it, right? It believes that it's connected to this 10.0.0 network. Even if it were to make it upstream, HQ could pick one or the other route, may or may not get there. Right? So because both routers believe they have 10.0.0.0 and HQ believes it has two routes to this 10.0 network, of which only one direction or one route can actually service one network, right? The direction towards branch 2 is the only one that can service the 10.1.4 network. The direction towards branch 2 can't service 10.1.3 or 10.1.2 or 10.1.1. So we'll go ahead and fix that by shutting off auto summarization. We'll do that on branch 1 first. We'll do, router RIP. No auto summary. Hit enter. I just tab completed it. I'll go ahead and I'm going to do that. I'm only going to do that in branch 1 or branch 2 for a second just because I want to show you something else. So I'll grab branch. So I've grabbed branch 2 and want to do a config T, router RIP. We're going to shut off summarization again. I just didn't tab complete it, but remember you can shorten a command as long as you get far enough through it that the router understands what you're doing. Oh, just to be sure, let's do a clear IP route just to make them update right away. We'll go ahead and do the same thing with branch 1. So I should have fixed that, but I didn't. Here's the command I put in. And then we'll go ahead and show our routing tables again. Alright, we cleared our routes just to verify everything. I know I've done no magic going on here, right? So now let's look at our routing tables. If we do a show IP route, we have the 10.0, and we're still seeing 10.0.0.0.8 via 192.168.1.2. We see these are all our directly connected networks. This is the way they've always been. Let's go back over to branch 2. See if our routing table has changed here at all. Oh, branch 2 believes it can get to the 10.0 network via 2.0. Let's see if they can ping each other. Let's go 10.1.3.1. Yay, successful. Over to branch 1. And we ping from branch 1, 10.1.4.1. The difference here is, you notice our routing tables are still showing this 10.0 network. The difference is when the updates go over and when the packets go over, subnet information is sent with it. So now I know that if the router knows, I guess not I know, now the router knows that it doesn't own 10.1.4.0. It knows within the span of 10.0.0.0 it has 10.1.3, 10.1.2, and 10.1.1, but through its updates it realizes that within that range of the 10.0 network, within the overall network, in order to get to the 10.1.4.0 network, it has to go through this route. Okay. Let's upstream so that we can also do some manual summarization. So we do a lot of summarization in order to keep our routing tables smaller so we don't have to send an update about every little thing that happens. So like if something would happen to say on branch 1 to network 10.1.2.0, but 10.1.3.0 and 10.1.1.0 are fine, we would have to send an update about that network. Maybe branch 2 doesn't need to know that. So we do summarizations, some to clear out some congestion, and sometimes so that we don't have to recalculate anything, and we'll talk about that more as we get into EIGRP and OSPF. So let's say we want to summarize our networks 10.1.1.0, 10.1.2.0, and 10.1.3.0. We summarize, basically you go, I won't do it bitwise, it's not really covered here, but if you haven't done summarization before, you can write it out via the bits, or if you can do it in your head, you go to the spot where they are, they first become different, cut it there, and then that's how many subnet bits are going to be needed. So in this example with 10.1.1, 10.1.2, 10.1.3, the first time they become different is after the second octet. So we're going to go ahead and summarize at the 10.1 boundary, and then look at our routing tables. So we're going to stick with branch 1, but we do summarization on the interface, and so what we want to do is we want to do it on the outgoing interface. We don't want to summarize it going towards our networks. We want to summarize as we advertise out to the rest of the world. So config T, and that interface is 0.1 IP, summary address. I'm going to hit a question mark here only to show you that both RIP and EIGRP will use this command under the interface. Here we're going to do RIP. The address we want to summarize is 10.1.0.0. Because remember, this third octet is where they all become different. We want to stay where they're the same because we can summarize them all into this one group of the 10.1.0.0 network. And then the subnet mask is 255, keep forgetting to move my mouse, 255.0.0. So my summary address that will summarize the 10.1.2, 10.1.1, and 10.1.3 networks is 10.1.0 with a 16-bit subnet mask. So go ahead and hit enter. And then we're going to go and I'm going to bring HQ up, and we're going to see that its routing table should now have a different route. All right, it should have our summary route. So we bring HQ over, we do a show IP route. Not here. Privilege exec, show IP route. I don't know why route seems to be so difficult to type. And now you see our summary address. Also, what you should notice that, well, what you should notice now, we should have checked before too, was that now we no longer have two routes to 10.0.0.0. We have a route to 10.1.0.0 to go through 1.1. And now if it wants to get to 10.1.4.0, it's going to go to 2.2. So now everything's going in the right direction. Everybody's happy. Our updates are sent properly. One last thing. Let's check branch 2. So branch 2. Now branch 2 shows, he doesn't show our summary route. He's showing that he can get to the 10.0.0 network by going to HQ. So his routing table is the same as it is was before. Why is that? Okay, because HQ still has auto summary on. So the manually summarized address gets to HQ. In fact, let's just pull our picture up for a second. I think that would probably be kind of useful right now. We've been doing a lot and trying to visualize some things. What's happening now is we've summarized, right? We've summarized now, and we know that HQ is getting 10, it's not getting 10.0. Let me get my pen back. HQ is now learning 10.1.0.0/16. But what's happening is auto summary is still on, so when he's advertising out, he's still auto summarizing or summarizing to 10.0.0/8, right? So he's still learning it. If I go ahead and turn no auto summary on here, we should be getting the right networks. We should be getting the summary address upstream from HQ. Let's just make sure that happens. Alright, so we go to HQ, we'll do a config T. RIP. No auto summary. I'll shut that off. We'll just wait and we'll go. I'm going to go grab branch 2 and hopefully he should get the new summarized address here. Got branch 2 over here. We'll do a show IP route. We are getting it now. We just have to clean it up. It just needs to be cleaned up a little bit. It will. So now we're getting the 10.1. The summary route is going to our summary route 10.1 is now being learned, and it knows that it can get to that by going through HQ. I'm gonna make my window a little smaller here. Let's go ahead and do a clear IP route. There we go. Now it's normal. Just need to be cleaned up a little bit, learn things, and it's got its timers and whatnot. We just want to wait. And so now it's gone, right? Now the one we had, the problem that, I don't know, it's a problem, but what we had earlier was this. Now we cleaned it all up. We'll do manual summarization, and the summary route is 10.1 with a 16-bit subnet mask. I think I'm going to leave this video here. I'm going to stop here because it's actually way longer than I would have wanted to be. I'm going to learn to talk faster or clearer or something. And I'm going to do RIPng in a separate video, so that'll be next.